Good morning, friends. We start our new chapter. Inspection of pressure relieving device. API recommended practice RP 567, 4th edition, April 2017. That is what required. April 27, section 5, 6.1, 6.3, 8, 10.1, 10.3. Okay. In between, I don't know. Something. We'll just check. So inspection of pressure relieving device. The recommended practice RP describes the inspection and repair practice for self-actuated pressure relieving device commonly used in the oil, gas and petrochemical industries. The publication doesn't cover training requirement for personnel involved in the inspection and repair of pressure relieving devices, ERV. So let us see terms and definition. Blow down. The difference between the set pressure and the closing pressure of a pressure relief valve expressed as a percentage of pressure in pressure set pressure or pressure unit. Set pressure and the closing pressure. The percentage of set pressure and pressure unit. CD tip. The pressure at which pressure relief valve is cooled to differential test pressure. The pressure at which pressure relief valve is adjusted to open on the test stand. The cold differential test pressure include correction of service condition or superimposed back pressure or temperature or both. Design pressure. The design pressure is equal to or less than MAWP. Galling. The condition whereby excessive friction between high spot result in localized welding with subsequent splitting and further roughening or rubbing surface of one or both two mating parts. Hodding chamber. The annular chamber located downstream of seat of the pressure relief valve. The purpose of assisting the valve to achieve lift. Mark burst pressure. The burst pressure is established by test for the specified temperature and marked on the disc tag by manufacturer. The marked burst pressure may be any pressure within the manufacturing design range unless otherwise specified by the customer. The marked burst pressure is applied to all the rupture discs of the same lot. Overpressure. The pressure increase over the set pressure of the releasing device. Overpressure is expressed in pressure units as a percentage of set pressure. Overpressure is the same accumulated only when relieving device is set to open at MAWP of the vessel. Pop pressure, the value of increasing static pressure at which disc moves in the opening direction at a faster rate as compared with corresponding movement at higher or lower. Qualified person, a competent person who has met the knowledge, skill, requirement, expectation of the owner user. The inlet curves pressure at which set pressure at which the pressure relief valve is set to open under service condition. So pressure relieving device. The pressure relief device is actuated by inlet static pressure and designed to open during emergency or abnormal condition to prevent the rise of internal fluid pressure in excess of a specified design value. The device may also be designed to prevent excessive internal vacuum. The device may be pressure relief valve, a non-closing pressure relief valve, or a vacuum relief valve. Common examples include direct spring-loaded pressure relief valves, pilot-operated pressure relief valves, Rapture disc, buckling pin device, and weight-loaded device. Pressure relief valve, safety valve. Pressure relief valve is designed to open the relief valve of excess pressure and reclose, thereby preventing the further flow of fluid after normal conditions have been restored. A presence relief valve open when its upstream pressure reaches the opening pressure, then allows fluid to flow until the upstream pressure falls to the closing pressure, and then closes, preventing further flow. The term pressure relief valve is generic in nature, and this device can be classified as safety valve, relief valve, or a safety relief valve. That is PRV, pressure relief valve. Safety valve. A safety valve is normally used with compressive fluids, air, gas, steam, service, refinery, petrochemical plant. Relief valve is normally used to incompressible fluids, allowing flow of the liquid. A safety relief valve is a pressure relief valve that may be used to either safety relief valve depending on the application. The trim of safety relief valve will provide suitable lifting characteristics on either compressible or incompressible media. Pressure vacuum relief valve. Tank connection, inlet air. outlet. Weight loaded emergency vent. Direct spring operated pressure relief valve. Open bonnet. Direct acting spring loaded pressure relief valve. Conventional direct spring operated pressure relief valve. Closed bonnet. Direct acting spring loaded relief valve. Balanced direct spring operated pressure relief valve. Pilot operated pressure relief valves. The self-actuated auxiliary pressure relief valve pilot, where a large relief area under and or high set pressure are required, where low differential exists, operating margin between the normal pressure equipment, vessel and piping, operating pressure and the set pressure of the valve, a large low pressure storage tank, a very short blowdown required. Where back pressure is very high, balanced design is required. Where very short blowdown is requirement, where back pressure is very high and balanced design is required, whose pressure conditions require sensing a pressure at one location, relief of fluid and another location, where inlet and outlet piping frictional pressure losses are high, and where in situ in service set pressure verification is desired. Rupture disc device, forward acting, reverse acting, graphite rupture disc. Rupture disc device is a non-reclosing pressure relief device actuated by static differential pressure between the inlet and outer outlet of the device and designed to function by bursting of a rupture disc. Pilot operated pressure relief valve. Diaphragm main valve. Pilot operated pressure and vacuum relief valve. Diaphragm valve, main valve. And forward acting conventional rupture disc. Forward acting screwed rupture disc. The reverse acting knife blade rupture disc. Reverse acting screwed rupture disc. Graphite rupture disc. Causes of improper performance. Let us see what is anything there in between. No. 5, 6.1, 6.3. Okay. So 5 Causes of improper performance. Corrosion. Corrosion is a base cause of many of the difficulties encountered with pressure relief device. So an understanding of process operating conditions and resulting damage mechanisms are required in order to establish and maintain the inspection program of relief valves that yields the highest probability of preventing their damage. Acid corrosion, carbon steel bonnet caused by leaking sheeting surface. And then chloride corrosion of 18 CR 8Ni steel nozzle with machined sheeting surface. Sulfide corrosion of carbon steel risk from crude oil distillation unit. Chloride attack on 18 CR 8Ni steel disc. Their expansion below speed type corrosion on 18 CR 8Ni steel bellows. Alloy 400 rupture disc corroded in shore gas service. Body and bonnet coated with epoxy for corrosion protection. The prevention action for corrosion, the rupture disc device installed on the inlet and outlet of the pressure relief device can provide added corrosion protection of the valve internals. Damaged seating surface, their optical precision on order of 3 light bead brands. Imperfection on seating surface may be contribute to improper valve action in service. Prevent leakage of the loading fluid and optical precision in the order of 3 light beads bands according to the manufacturer's specifications should be maintained in flatness of seating surface on metal seated pressure relief valve. API 527. So seating surface of disc deformed by chattering. Proper handling during maintenance and or transport such as bumping, dropping, jarring, scratching over the wall part. Corrosion, foreign particles introduced in the valve inlet that pass through the valve when it opens, such as the mill scale, welding spatter, slag, corrosive deposits, coke or dirt. The particle may damage the seat to nozzle contact required for tightness in most pressure relief valves. The damage can occur either in the shop during the maintenance of the valve or while the valve is in service. High inlet pressure drop may be caused by improper piping design or lengthy piping to the valve inlet or obstruction in the line may cause valve to chatter. The pressure on the disc may become great enough to open the valve, but as soon as the flow is established, the pressure drop on the connecting piping may be so great that the pressure under the disc falls and allows the valve to close. The cycle of opening and closing may become rapid and subject the valve seating surface to severe hammering, which damage the seating surface sometimes beyond repair. Failed spring. General spring failure occurs two forms. Weakening of the spring, possibly a premature opening. Second is a mechanical failure, complete break, uncontrolled valve opening. The spring may be weakened and fail due to the use of improper material at high temperature service. Failed springs are almost always caused by corrosion. Spring failure due to corrosion, due to stress corrosion. Inlet nozzle plugged with coke and catalyst after 9 months in reactor vapor line. Outlet bulb plugged with deposits other valves in common discharge header. Moving parts of the valve fouled with iron sulfide. Disc frozen in guide because the buildup of products from corrosion in sour oil vapor service. Gulling. Improper handling general. Improper storage valves. Relief valve can cause change in set pressure, damage lifting valve, levers, damage tubing fittings, damage pilot assemblies, cause internal leakage when the valve is in service. During shipment, pressure relief valves should be braced and shipped in the upright position. This is especially true large valves and valves with low set pressure. And during maintenance, lifting lever wiring is only used for transportation and need to be removed before installation. Avoid exceeding the pressure rating, the bellows during the back pressure test, as this may damage the bellows. Pressure relief valves should be installed in a vertical orientation with a disc on a direct acting valve or unbalanced member. A pilot operated valve oriented horizontally so that a disc or unbalanced member moves forward as the valve opens. Regions for inspection and testing. Pressure relief devices are installed or process equipment to release excess pressure during operational offset external fires and other hazards. These hazards are discussed in API 521. Failure of pressure relieving device to function properly when needed could result in overpressure of the vessel exchanger boiler or other equipment they are installed to project. A properly designed, applied and installed pressure relieving device that is maintained in good operating condition is essential to the safety or of personnel and the protection of equipment during abnormal circumstances. The principal reason for inspecting pressure relieving device is to ensure that they will provide this protection. Inspection of pressure relief devices should determine the general physical and operating condition of the device and ensure that their performance meets the requirement for a given installation. And making this determination, four type of inspection can be used. The sub-positive pop test, sub inspection overalls, field internal inlet and outlet piping inspection, and visual on-stream inspection. Pre-testing and post-testing of the pressure relieving device should be included in the sub inspection overall, which is discussed in the following section. SOP inspection overall covering inlet outlet piping connection should only be done to verifying that the connected equipment is not to be adversely affected, subjected to excess vacuum. The general periodically pressure relieving devices will be removed, disassembled and inspected. These inspections are referred as sub inspection overall. Although some, if not all, the work can be performed in the field. Safety 6.3 valve identification. To minimize errors in the testing and handling of pressure relief valves, each should carry an identifying tag, stencil plate, or other means to show it is company equipment number. The number readily identifies the device unit. The equipment shall be equipment that the device should be installed on, and device set pressure, and the date of last test. Figure 3840b examples of identifying tag. If a relief device cannot already be easily and correctly identified, marking on it, it should be marked and identified as described above before it is removed from the equipment. Also, SME BPC Section 8 Division 1 Paragraph UG 129 for the instruction of making nameplate. For pressure relieving devices, it is recommended that the original manufacturer's nameplate should always remain on the pressure relieving valve. Caution should be taken not to paint over the tab. FCC U number 3 1 2 C321 like this identification Anderson Greenwood Crosby the number tag and this SMA UV identification tag for pressure relieving device mandatory January 1 2013. Identification tag for a pressure relieving device PRV. SOP inspection, testing, maintenance, and setting the direct acting spring-loaded pressure relief valves used for on-fired pressure vessels. Determining as received pump pressure whenever possible, as received pump testing should be conducted prior to cleaning in order to yield accurate as received pump testing result that will help establish the appropriate inspection and servicing interval. Dismantle set pressure of the valve should be obtained before the valve is dismantled, and the pressure at which the valve relieves is recorded as received pump pressure. Caution: if the valve is extremely foul and dirty when received, and as received action, valve may damage the valve sheet. The user may waive the as received test and instead reduce the inspection interval. Setting of valve set pressure. The deviation of as found set pressure of the nameplate set pressure should not exceed plus minus 2 psi, plus minus 15 kPa, less than equal to 70 psi, for pressure less than equal to 70 psi, 500 kPa, plus minus 3% for pressure greater than 70% psi, 500 kPa. CSM is section 8 division 1 paragraph UG to 134. Inspection, testing, maintenance, and setting up direct acting spring-loaded valve on equipment. There are potential hazards when applying lift assist test method. The potential failure of the rupture disc in rupture disc valve combination. Possible introduction of foreign material into the valve fitting area, which may result in mechanical damage and or leakage through the valve upon reset. Possible release of process material to atmosphere. Potential failure of bellows. The bellows seeking valve will cause release of pressure to atmosphere through the valve bonnet opening. Most devices are electronics and such should be analyzed and their suitability to hazardous environments. The valve may not restart tight following test, necessitating action appropriate for valve leakage. Testing with inlet pressure near the set point of the valve may cause the valve to open, necessitating a reduction in operating pressure of a mechanical device to close the valve. Caution: this method of checking and set pressure and functioning of safety valve identifies the opening pressure and should not be considered a routine activity for determining the integrity of the pressure relieving device. The lift assist test method for checking the set pressure for a pressure relief valve doesn't satisfy the need of check for inlet outlet line fouling or remove a valve. Physical inspection and verification that all its components are in satisfactory safe working condition. The lift assist test method also doesn't verify the valve blowdown setting and set leakage at 90% of the set pressure of the valve. Generally more economical, effective to perform SOP inspection overall to SOP at the required intervals then on its equipment. However, when a valve operates and non-fouling service, experience may be indicate that inspection of the valve while the equipment safe and suitable. When suitable safety precautions have been taken, the inlet outlet block valves may be closed and the bonnet of the valve may be removed for immediate inspection testing. Any minor repairs may be by a qualified person. When major repairs are indicated, the valve should be sent to the shop. Okay, 6.1, 6.3, and 8, then the 5 total, 8 total. Okay. I don't know why in between something is there. Pressure relief valve visual on-stream inspection. Full visual on-stream inspection includes but is not limited to ensuring the following: the correct relief valve was installed, company identifications, tags, stencils provided means to establish the last state, proper pressure setting for the equipment protected by the identified device that informed in 8.1 matches the equipment file records as the established test intervals has not been exceeded. No gags, blinds, closed valves, piping obstructions would prevent the device from functioning properly. Seals installed to protect the spring setting and ring pin setting have not been broken. The relief device doesn't leak. Pressure relief valves that have opened in service frequently leak. Detection of correction of leakage eliminates the product loss and possible pollution and prevent fouling and subsequent sticking on the valve. The valve is a bellow valve. The bellows vent should be checked for leakage. Bellows vent are open and clear, and the connected piping is routed to a safe location. These vents should always be reference to atmospheric pressure. Upstream and downstream block valves are sealed and chained and locked in the proper position. Device that ensures that block valve is in its proper position include locking plastic bands, car seals, chains, and padlocks, and special locking device made specially for certain types of block valves. The field conditions should mirror the applicable piping and instrumentation diagram. P&ID, vent stacks, outlet piping, and small nipples are properly supported to avoid breakage, leakage. Inadequately supported or anchored nipples can be damaged during maintenance and by vibration. Valve body drains and vent stack drains are open. Stack covers are installed properly. Buck vents and rain vents. The drain holes and pressure relief valve, vent stacks and free of corrosion are not plugged. Any lifting lever is operable and positioned properly. A heat tracing insulation or purge that is critical to the proper operation of the relief system is intact and operating properly. A gauge installed as part of a combination of a Rapture disc and a pressure relief valve, or a device for checking pressure between a pressure relief valve and a block valve is serviceable. Verify that there is no pressure buildup between the Rapture disc and the pressure relief valve. Any Rapture disc is properly oriented. Remote pressure sense lines for pilot operated valve are properly connected and open. Ghost relief event. Although the interval selected for the stream inspection should vary with the circumstances and experience, a visual inspection that includes check for leakage, vibration, and the damage, loose fasteners, insulation, missing rain caps, deformation components, should follow each operation of a pressure relief device. Operating personnel assigned to the process unit may make these inspections provided that they are experienced to recognize any leakage or vibration damage for pressure relieving device. In potentially fouling service, consideration should be given to servicing the pressure relieving device as soon as possible. Inspection frequency. Test and inspection intervals pressure relieving devices in typical process service should be not exceed 5 years for typical process service and 10 years for clean, non-fouling and non-corrosive service. Frequency of visual on-stream inspection. The maximum interval for visual on-stream inspection should be 5 years. General records and reports. So a suitable system of keeping records and generating reports is essential to the effective administration and control of any pressure relieving device or device program in a process industry. So primary objective for keeping records is to make available the information needed to ensure that the performance pressure relieving device meets the requirement of their various installations. Responsibilities. The duties and responsibilities entitled to various facets of an inspection and testing program for the pressure relieving device should be clearly defined to avoid confusion and be explicitly assigned to assure compliance. The responsibility of engineering and inspection may include but not limited to the following: to furnish the specification, sizing calculation for relief device and connect piping, determine allowable pressure setting, to specify test intervals, to record service data, to prepare the list of device due to inspection, review inspection and overall results, identify the addressed issues, review approved and or purchase replacement bulb spare parts to ensure PNID match, field installation and equipment protected, conduct visual on-stream inspection at the requisite interval, to conduct profile radiography in inlet and outlet piping in specified intervals looking for corrosion and fouling, to ensure that new or modified equipment is reviewed for adequate overpressure protection. The responsibilities of operation and or inspection may include, but not limited to, initiate work request, see the device or installed in the proper location, prepare in-service reports, check for the leaking valve and rupture disc, to ensure that correct block valves, if any, are locked or sealed open and closed as required, check vents and drains for operability, to check the upstream and downstream piping for blockage and to perform condition assessment inspection. The responsibilities of maintenance may include but not limited to the following: to perform the mechanical work required to repair, test, reinstall, and attach identification tags to the devices, to maintain specification records, facilitate repairs, to furnish test reports, to initiate purchase orders for spare parts. The sample records in Annex B. Make body bonnet material unit location, set pressure, test interval, remarks, all like this. Okay. Thank you, gentlemen. We'll stop.